Along the San Francisco Bay region and the century-old levees of Germany, millions of dollars are being spent every year just to fight a tiny enemy, the Chinese mitten crab. These armored biological drilling machines burrow into levee systems and cripple urban pumping stations. But on the other side of the planet in China, a species once regarded by the West as an ecological disaster is carefully cultivated right on flooded rice paddies, covering hundreds of thousands of hectares. At luxury dining tables, a single mitten crab can be priced as high as a premium cut of Wagyu beef, becoming a signature centerpiece of a seafood industry worth more than 100 billion yuan every year. So what really happened to this crustacean? The Chinese mitten crab, scientifically known as Ariochir sinensis, originates from the lower reaches of major East Asian river systems, such as the Yangtze River, the Yellow River, and areas around the Korean Peninsula. In this native environment, it has been a natural part of coastal freshwater ecosystems for thousands of years. However, this small crustacean has a very unusual life cycle. It is born in brackish estuary waters, then migrates upstream for hundreds of kilometers, deep into freshwater rivers and lakes to grow. When fully mature, it returns to the estuary to reproduce, completing a migration cycle that extends across almost the entire river basin. This two-environment migration cycle allows the Chinese mitten crab to pass dams, cross road networks, and even move between different river systems, an evolutionary advantage that makes it one of the most effective travelers in the freshwater crustacean world. At the beginning of the 20th century, these eastern travelers found a free ticket to cross the oceans, the ballast water systems of international cargo ships. When these massive ships discharged water at European ports, millions of Chinese mitten crab larvae were accidentally released. In 1912, they were first recorded in Germany. Within just a few decades, this small crustacean rapidly spread across major river systems such as the Elbe, Weser, Rhine, and Oder. A single mature female crab can carry between 250,000 and 1 million eggs each breeding season. By the 1930s, the number of crabs in Germany was no longer counted individually, but by the ton. In 1936 alone, the German government had to build large-scale incineration facilities to destroy more than 700 tons of crabs collected from the rivers, simply to keep inland waterways functioning. At one trapping station on the Weser River Dam, as much as 750 kilograms of crabs were captured in a single day. More dangerously, mitten crabs dig burrows up to 0.5 meters deep into levees and canal banks, creating millions of cavities inside the soil structure. When their density rises to hundreds of thousands per square kilometer, the surface of the Elbe River levees becomes riddled with holes like a giant block of Swiss cheese. With just one heavy rainfall event raising water levels, entire flood control systems can begin to sink and leak seriously, causing economic damage of more than 80 million euros in Germany. And this disaster did not stop in Europe. Somehow, these small travelers continued crossing the oceans and eventually reached the west coast of the United States. Chinese mitten crabs were first recorded in California in 1992. By 1998, major water pumping stations across the state reported hundreds of thousands of crabs being pulled into filtration systems within just a few days, causing severe blockages at both urban and agricultural water intake facilities. Turbines, pipelines, and filter screens became jammed, forcing multiple pumping stations to shut down for emergency cleaning. And the damage did not end there. The crabs also invaded commercial fishing traps, consumed bait, tore apart expensive nets, and depleted populations of small native fish species. According to estimates, the arrival of this small crustacean has caused losses of more than 20 million US dollars per year to the region's fisheries sector alone. Faced with a growing ecological threat that endangered both flood control infrastructure and inland navigation systems, Western countries could not remain passive. Large-scale defense campaigns were launched using some of the most advanced biological control methods available at the time. As early as the 1930s, Germany installed industrial trapping stations along major rivers such as the Elbe and Weser. intercepting seasonal crab migrations before they could spread farther inland. Hundreds of tons were captured each year and destroyed simply to protect levees and waterways. Even with layered strategies, including migration traps, reinforced earthen levees, long-term population monitoring, and stricter ballast water regulations in places like California, authorities still struggled to contain the species' explosive reproduction. The more they tried to eliminate them, the faster they seemed to spread, trapping Western countries in a costly defensive cycle. Yet while these nations fought to control the invasion, another country across the world began to recognize in the same crab a powerful economic opportunity. In China, the Chinese mitten crab is a native species, part of the natural food chain, and has been harvested by people for thousands of years. Across the lower reaches of the Yangtze River, through Jiangsu, Zhejiang, and Anhui provinces, mitten crab farming has developed into a large-scale industrial production system. At the center of this system is Yangcheng Lake, often described by food lovers as the Bordeaux of crabs. Each year, China's fisheries sector supplies about 700,000 to 800,000 tons of mitten crabs to the market, supporting an industry worth tens of billions of yen. However, the real strength of this industry lies not only in production volume, but in a special agricultural structure, the two-layer rice crab ecosystem. Instead of treating crabs as crop pests, Chinese farmers created an environment where rice and crabs form an efficient, symbiotic relationship. Rice plants provide shade and oxygen at the surface, while crabs move below, loosening the mud and naturally removing weeds and harmful insect larvae. In return, crab waste becomes organic fertilizer for rice roots, allowing the system to operate with almost no agricultural chemicals. More importantly, mitten crabs are very sensitive to toxic residues. Their survival in rice fields acts as a natural organic certification for the rice. As a result, rice crab rice is positioned as a premium ecological product with higher market value than conventional rice. On the same farming area, farmers can harvest both high-quality clean rice and high-value specialty crabs, creating a dual profit model that traditional monoculture farming rarely achieves. Building on these existing ecological advantages, mitten crab farming is opening up a production approach that is significantly more efficient than traditional livestock systems that consume large amounts of resources. To produce 1 kilogram of beef, more than 15,000 liters of water may be required, along with vast areas of grazing land and considerable methane emissions, while pig farming depends heavily on imported soybean meal and fish meal from global markets. In contrast, mitten crabs are natural omnivores capable of utilizing bottom-dwelling organisms, small snails, low-value fish, aquatic plants, and even local agricultural byproducts such as sweet corn. As a result, they can efficiently convert low-value biomass into a specialty protein with high economic value, while also reducing pressure on agricultural land and industrial feed supply chains. After about 6 to 8 months of growth, mitten crabs enter the harvesting stage, the phase that most strongly determines the commercial value of the entire farming cycle. Unlike many industrial livestock systems that focus on rapid weight gain to shorten production time, mitten crab farmers often extend the final growing period so the crabs can fully develop their roe, which is rich in lipids and proteins and plays a key role in their distinctive flavor and market value. The harvesting season usually lasts from September to December, when slightly cooler water temperatures allow roe development to reach its peak condition. Instead of harvesting all crabs at once, farmers carry out selective harvesting in multiple rounds by placing traps along irrigation channels, rice field edges, and natural movement paths to capture individuals that have reached optimal commercial size. Crabs that have not yet met size and weight standards remain in the rice canal system to continue growing for later harvest rounds. This staggered harvesting strategy helps extend the production window, distribute supply across the season, and improve the overall economic return of the farming cycle. As a result, on 1 hectare of integrated rice crab farming land, total income can be 2 to 5 times higher than rice cultivation alone. In key farming areas around Yangcheng Lake, crab production can account for up to 70 to 80% of total profit per hectare. Right at the farming sites, mitten crabs are carefully sorted by shell hardness, weight, roe content, and gender. Early in the season, female crabs usually command the highest prices because of their thick, rich roe, while later in the season, male crabs become more desirable as their meat reaches maximum firmness and texture. Before transport, each crab is tied securely with string to limit movement and reduce damage during handling. The crabs are then temporarily held in clean water or recirculating tanks to remove mud and stabilize their condition, helping them survive longer transport distances. The next critical step is low-temperature oxygen-packed storage at around 5 to 10 degrees Celsius. This places the crabs into a minimal activity state while keeping them alive for shipping. They are immediately transferred into high-speed cold chain logistics networks, allowing deliveries to major cities such as Shanghai, Beijing, and Guangzhou within 24 to 48 hours. In premium farming regions such as Yangcheng Lake, each crab is fitted with an identification ring and traceability code to verify authenticity. Today, Chinese mitten crabs are no longer just seafood. They have become a high-end specialty product that can be ordered in the morning and delivered the same day in many major Chinese cities. If in Europe and the United States the Chinese mitten crab is considered an invasive species that must be controlled, then in China it is a symbol of autumn cuisine, with a culinary tradition that has lasted for hundreds of years. Each year, China's domestic market consumes around 700,000 to 800,000 tons of mitten crabs, supporting an industry worth tens of billions of yen. In the culinary culture of the lower Yangtze River region, autumn is not only the crab harvest season, it is also the season for enjoying mitten crabs with Shaoxing yellow wine, a ritual long associated with refined dining. The value of mitten crab lies in its distinctive flavor. The meat is naturally sweet, firm, and aromatic, while the crab roe is rich and creamy, with a texture similar to salted egg yolk blended with butter, the key reason for its premium status in Chinese cuisine. The most famous preparation method remains steamed crab with ginger and black vinegar, a simple technique that preserves the crab's natural taste. Crab roe is also used in iconic dishes such as crab roe xiaolongbao, where even a small amount of roe can raise the value of a basket of dumplings to dozens of dollars. Even smaller or damaged crabs are not wasted. Instead, they are processed into premium dishes like crab roe noodles, where the golden sauce made from multiple crab roe portions can push the price of a single bowl in Shanghai to $50 to $100. But to fully explain the boundary between disaster in the West and a gold mine in China, we must look deeper into two major structural differences. The first is infrastructure compatibility. The mitten crab's habit of digging burrows up to half a meter deep becomes a critical threat that weakens Europe's hard-engineered levee systems. But when China introduced the species into soft infrastructure, such as shallow rice paddies, this same burrowing behavior turned the crabs into natural soil engineers, loosening sediment and supplying oxygen to plant roots. The second difference lies in culinary economics. People in Western countries generally do not eat freshwater crabs, so the species is effectively treated as biological waste. In contrast, China's long-standing culture of appreciating seasonal delicacies has activated a billion-dollar market, creating strong incentives to operate a professional supply chain and branding system around the species. The final and most fundamental difference lies in ecosystem management strategy. The West tends to view nature as a threat and responds with elimination, remaining trapped in a defensive cycle. China, by contrast, views nature as a resource and chooses planning and active utilization. In the end, whether a species becomes a disaster or a resource is not determined by the species itself. It is determined by whether human economic systems are designed to work with the flow of nature or against it. The story of the Chinese mitten crab reveals an important lesson. An invasive species is not always an absolute enemy. In many cases, the problem does not lie with the organism itself, but with the system in which it appears. In Europe, when mitten crabs interact with flood control levees and urban water management infrastructure, they become a serious engineering risk. But in China, when the same species is placed within biologically integrated rice paddy systems, it turns into a large-scale economic resource. This shows that infrastructure design and agricultural models are the key factors that determine how dangerous an introduced species can become. And the biggest lesson is this: when properly integrated into a production ecosystem, a biological risk can be transformed into a valuable resource. A small crab once crossed half the planet and became a threat to levee systems in Europe and North America. Yet in China, it was transformed into a specialty industry worth billions of dollars. The story of the Chinese mitten crab shows that the future of the same species can turn out completely differently depending on how people choose to respond to it. It can become either an infrastructure threat or a valuable economic resource. And sometimes the line between a dangerous invasive species and a national specialty product is separated by nothing more than the right strategy. If you would like to explore more engineering paradoxes like this, don't forget to follow Mandarin Tech.